Hi Trig students, this is Megan. I had a few things come to my attention from today's lecture that I wanted to talk about. So this is from Wednesday, October 1st in section 8.3. One of the examples that we did on the board today was solving the sine of 2 theta equaling 1/2. And there was some confusion among some students about the answers, and there's a good reason for that. What I had written on the board was actually not correct, and I didn't realize it until someone brought it to my attention. So let me help you out and help you understand what was happening there. So in terms of solving this, our initial step was a good one. So the first thing we wanted to do is we wanted to isolate the theta by inverse signing both sides of the equation. So we had done that in class, and that was fine, no problem there. And the reason that we inverse sign both sides is so that the sine inverse and the sine would undo each other, and we'd isolate that to theta. Then what we did was we used our unit circle to evaluate the inverse sine of 1/2. So I'm going to pull out my unit circle. And since sine is the y-coordinate, I'm looking for where on the unit circle is the sine value 1/2. And it happens twice. It happens here at pi over 6, and it happens again here at 5 pi over 6. So 2 theta is equal to pi over 6, and 2 theta equals 5 pi over 6. Okay, so we had done that in class, but we want to remember that we're trying to find the general solution. And so with the general solution, that could be with any number of revolutions around the unit circle. So to each of those angles, we're going to add multiples of 2 pi. Okay, so if k equals 0, then we're not adding any 2 pi at all, and our solution is pi over 6. If k equals 1, then we're taking pi over 6 and we're adding one more 2 pi. If k equals 2, then we're adding 4 pi. Same thing over here. But the error that I had made that I didn't notice was we are solving for theta here, and what we have is 2 theta. So what we need to do is divide both sides of the equation by 2 in order to isolate that theta. So with the first equation, we get theta equals pi over 12, which was our answer in class. But what has to also happen is that this period here also needs to be divided by 2. So one of our general solutions is pi over 12 plus pi k, not 2 pi k, as I had initially written. And then the same thing over here, I need to divide both sides by 2 to isolate that theta, but I need to do it in the 2 pi k part as well. So 5 pi over 12 plus pi k, not 2 pi k. Alright, so this is our general solution, or 2 general solutions. And if we wanted to list the first 4 solutions, we'd have pi over 12, we'd have 5 pi over 12. Okay, so those 2 are the same as what we had in class, but now we need to add just a pi k, not a 2 pi k. So if I add pi k to this, I'm going to get 13 pi over 12. And if I add pi k to this one, I'm going to get 17 pi over 12. So again, these 2 answers that we had initially written, or that I take responsibility for that, had initially written on the board were not correct, because we also have to divide the period by 2 as well. Okay, so that's one example that I wanted to go over. Another example that I wanted to go over that I would have done in class today if I had more time would be to do something with a tangent by hand. I know we did one equation in class where we used the calculator to solve a tangent function, tangent equation, but let's do one by hand. Okay, so this is a good example that I would have done had I had more time in class today. One of the things you want to remember are the periods of the different functions, the periods. So when we're working with sine, cosine, secant, cosecant, the period of all of those functions is 2 pi. So in our general solution, we have to add 2 pi k. But when we're dealing with tangent and cotangent, the period is 1 pi. So when we get our general solution for any tan or cotan functions, we're just going to add 1 pi k to do one full revolution around the circle. Because again, that's the period of tangent and cotangent. So let's try to apply that to this problem, and that's why I chose tangent here. So the first thing that we want to do in this equation is get rid of the tangent. So how do we undo tangent? Well, we inverse tan. And what you have to remember to do is inverse tan, or inverse anything, both sides of the equation. Alright, so tan and inverse tan cancel out, and I'm left with theta minus pi over 2 equals, now let's use our unit circle to figure out what it equals. Where on the unit circle is the tangent equal to positive 1? Well, that's going to happen here at pi over 4. So when I divide sine and cosine, I'll get 1. And it's going to happen again down here at 5 pi over 4. When I divide these two x and y coordinates, y divided by x specifically, I get a positive 1. So I get 1 pi over 4, and then I also get 7 pi over 4. But again, we want to write the general solution, so we're going to add 1 pi k to each of those angles. Then we're going to solve for theta. So again, that was the mistake that was made up here earlier on this example. We divided by 2 and then we added 2 pi k. And we should have added that 2 pi k first, then isolated the theta. So let's continue down here in solving these equations. I'm going to start with this one first. So to get theta by itself, I'm going to take this pi over 2, the negative pi over 2, and I'm going to add it to both sides. So pi over 4 plus pi over 2 plus pi k. And then if I solve this equation for theta, I'm also going to add pi over 2 to both sides. And we'll just combine some like terms. So notice here with addition or subtraction isn't going to affect that period the way that it did with division. Okay, so if we're dividing, we have to divide every single term by 2. Whereas with adding, we just have to do it to both sides. Just the nature of how arithmetic works, really. Let's finish this off by getting a common denominator and combining these like terms. So that would be 1 pi over 4 plus 2 pi over 4. So 3 pi over 4 plus pi k. And then over here, 7 pi over 4 plus 2 pi over 4 is 9 pi over 4. Plus pi k. So those would be our general solutions. And then I think in this problem, which is in your textbook, they give a range of answers between 0 and 2 pi. And actually, I just noticed that in my math lab, you have to watch out for this. A lot of times that will actually be just a less than symbol, and I automatically write less than or equal to. But a lot of times the given window is just strictly less than, so you want to pay attention to that. So we're looking for any of these solutions that might be within this window. So 3 pi over 4 clearly is. And then if we add pi k to it, so I'm going to take 3 pi over 4 and add 1 pi, that gives me 7 pi over 4, and that is within our given range. If I add another pi to that, that's going to be 11 pi over 4, so that's too big, and that will be out. Take a look over here. Already 9 pi over 4 is too big, so that's also going to be out, and any additional period of that will be out as well. So these are the solutions that we're looking for between 0 and 2 pi. Alright, one last thing I'm just going to mention. In class today, I said that MyMathLab might be kind of picky about how you write your solutions in terms of using these curly brackets. It turns out I took a look at the MyMathLab and they'll just give you a blank each time to type your answers in, and you won't have to worry about using proper notation. So no worries there. Another thing to note is that if you wanted to see these two examples worked out one more time, you would look at page 623 and page 624 in your textbook. And each one of those examples will be located on one of those pages. Alright, so hopefully that helps clarify a few things. Good luck doing your homework this weekend.